Alright guys, I've got a question here just to illustrate some of the key concepts when it comes to analytical geometry. It says here, this question is from a past paper from 2012. I know you guys, you don't go as far as 2012 or 2010 or something, so this is far way back, but I think it does really carry in key concept, especially when it comes to the last question, because I know most of my learners struggle with this question. It's worth 6 marks for this paper, so I know when they bring questions like this, you guys will say no, it's difficult and whatnot. So I would really advise for you guys to stick around on this video up until the end. If you are new here, please make sure that you subscribe. Welcome to Maths with Gaston. So please, the last question is very key, but we really need to go through the other ones as well. All right, it says that A, B, C, and D, it's a rhombus. The diagonal bisect each other at point M. So the fact that they said it's a rhombus, this tells us that these lines here, they are therefore parallel. So this line and this line here, they are therefore parallel, which means if lines are parallel, their gradients are the same. So I hope that is clear, guys. I hope you can remember that from the lesson video that you watched previously before this one. If you haven't watched that video, please make sure that you do have a look at it after this paper, or you can watch it when you get a chance. All right, and then they said E is just a point that lies on BC. Right, we can see that B, we don't have a coordinates, and then M also don't have a question, the coordinates rather. So now let's move on to question number one. Question number one said find the coordinates of M. So we can see that M, immediately when they said diagonal bisects each other, it means this M here, it's what? It's a midpoint. So we would know from our formula sheet how to find the midpoint. So let's go ahead and do that. M, which is going to be our midpoint, is going to be x1, or rather the way my learners prefer to do it is gonna say x at point A plus the x at point C all over 2, and then also you're gonna have the y at point A and then plus the y at point C. But however, even if you use x1 plus x2, it really doesn't matter, guys, as long as you do what you are comfortable with. So this would be at point M. So I'm going to start with the one at A. X is what? Is -3, and then at C, our x is what? Is +5, therefore divided by 2. And then what do we have here? We have got y at point A, it's 8 plus or -4 all over 2. So now in this case, we're gonna come here and say simplify further. -3 plus 5 will give us 2 over 2. Therefore here we're going to have 8 minus 4, which is going to be 4 over 2. So therefore it means coordinates at point M, they are therefore given by 1 is to 2, which kind of makes sense. This is 1 is to 2. Okay, great stuff. And that's just simple plug into your formula and then follow the steps thereof. Okay, now they're asking us to calculate the gradient of BC. Gradient, small letter m, of BC is given by y at, okay, BC is this one here. We need 2 points for the gradient. So now this time around, let me use y2, y1 all over x2, x1, so that you guys can see that basically these things are the same. I'm gonna choose this one as my first coordinate. This one will be my second one, right? Because they're on the same line, so I can also use E as a point there. Okay, so therefore it's going to be equal to, I said what? Okay, the y is gonna be -4 minus 1 all over x, which is 5 minus 6, right? So basically you can see, guys, if you follow the basics, you shouldn't really struggle at all. This will be equal to, at the top, what do we have? We've got -5, and then here at the bottom is gonna be 5 minus 6, which is what? Which is going to be -1. Therefore negative over negative in this case will give us a +5. Okay, and that's how you would deal with the gradient. And then they said to us here, find the equation of AD. So they're looking for this equation of this line here. They are looking for equation of the line AD. So therefore you're gonna come here and say, all right, if they are looking for the equation of AD, what do we have? We only have one coordinate, which is the point A there. But however, we know that line AD, it's also parallel to line BC. Okay, reason being, this is what? This is a rhombus. So if this is a rhombus, then these two lines will be parallel, which simply means the gradient of AD is equal to the gradient of BC. So therefore, what we know about the gradient of AD is equal to that. We know the gradient of BC is equal to 5. Therefore, we're gonna come to our equation here. Said M gradient of AD x plus C. So do we have a point here? Yes, we've got a point that we can substitute A in order for us to be able to get the coordinates of, to get the point C rather. So our y will be 8. It's equals to, what is the gradient? The gradient is 5, and then our x is -3 plus C. We are simply doing this so that we are able to find what is C. So it's going to be 8, and then this is what? -15 plus C. Take 15 to the other side. 8 plus 15 is equals to C. C is going to be equal to, so if you take how much is going to be this? It's going to be 23. Okay, take 5 there, we are left with 3 is going to be 23. Therefore, the equation of AD is going to be given by 5x plus 23 plus 23. Okay guys, and that's how you deal with a question like this one. Right, so let's move on to question number 4. Right, okay, question 4 says find the size of theta. So theta is this angle sitting right here. I want us to find the size of theta. So but what we can do in this case, we know that this line, if this is a rhombus, we know that these lines are parallel, but they are also equal to each other. Okay, so if these two, they are equal, it also means this angle here is also equal to theta as well. Because why do we say that? We, from Euclidean geometry, guys, you would know that equal size, okay, they suspend what? Equal angles. Equal size, this is what? Equal size. They also give us what? Equal angles, which in this case is going to be that angle A there should be equal to angle C, because of what? They are suspended by equal sides. So therefore, guys, do we have the gradient of AC so that we are able to get the angle of inclination, which is this angle here? Okay, do we have the gradient of AC? We don't have, so let's go ahead and look for the gradient of AC. Okay, so we're gonna come here and say, okay, AC, remember guys, AC is equals to tan, the gradient was going to be AC is equals to tan R, which is what? Our angle of inclination. So let's find the gradient of AC. So we're gonna come here and say, okay, gradient of AC is going to be given by the y at A minus the y at C all over the x at A minus the x at C. So what is the y at A? Is going to be 8 minus into minus 4. Minus 4 here, guys, don't forget your negatives, and therefore x at A -3 into minus 5. So therefore AC will be equal to, excuse the noise guys, here at the top is going to be 8, negative plus is going to give us 12, then at the bottom is going to give us negative 8 rather, I almost wrote negative 6, which is going to give us 2 goes how many times here, it goes 6 times, 2 goes how many times here, it goes 4 times. Okay, let's see here guys, it's really bad the noise, but just bear with me. I've got no control over the people making noise right now. Okay, all right, then let's see. Okay, here it's going to give us 6, and then 2 goes how many times here, it goes 4 times, therefore 2 also goes 3 times here, and it also goes 2. Yeah guys, you'll see when I'm doing this, just know that I don't have a calculator, right? So but let's not forget the negative here. All right, so therefore now what we can do, we can come here and say, okay, therefore tan, using this equation right here guys, tan r is equals to negative 3 over that. Okay, so now let me see this. Please go to your calculator guys and go and do shift second function, negative 3 over 2. Right, let me check on my calculator here while you guys are also checking. What you can do also, you can pause the video to see if we are on the same page. Okay, shift, let's see, we're saying shift tan in brackets negative 3 then over 2, then therefore you close the bracket here. It is giving us negative 56.31 degrees. Okay, but however guys, you know we can have a negative angle, so you must know that you should know that this one you need to minus it from 180. Where is tan negative? Is negative on the second quadrant, where we're going to have r is equals to 180 minus 56.31. This will therefore be that answer there, plus 180. Okay, let's see, 180 minus, excuse me guys, I hope you guys are also following. I'm just struggling with the calculator a bit. I know sounds a little bit tricky to say. Right, so our r, thank you very much for saying that, turbo, it's gonna be 123.69 degrees. So therefore this means this angle right here, which is angle r, is 123.69 degrees. And then therefore now we're not done yet. Remember guys, now we also need to find this angle here. Okay, this angle here, you can find it by using the gradient of BC. So let's go back to our equation and find out what was the gradient of BC. I think it was 5. Let's go back. Yeah, gradient of BC, it was 5. Okay, so it is 5 here, which is going to be equals to tan. This one will give us the angle of inclination of here at BC. Right, so it's going to give us this angle here at BC. So let's see, it's going to be the angle along BC. Okay, so now it means now you're gonna come here and say the second function tan 5, what does it give us? It gives us the angle of inclination along the line BC. I'm just gonna call it BC for the sake of calculation and also understanding as well. So now let's go ahead and punch this in our calculator. Let's see what we're gonna get. Okay, let's do this together guys. I hope you are following. I'm being a bit slow so as to make sure that we are on the same page here. Right, So this is giving me 78.69 degrees. This is the angle at BC. So it gave us this angle. But remember, guys, a line and a line, if you've got an angle here, what do you call this? Vertical opposite angles. So it means what? We can know this angle here, it's also going to be the same. So this angle here will also be 78.69. It's looking good so far. So now, guys, what do we have here? We have got this triangle here. Let me draw it in such a way that you guys will be able to see it. We've got a point C here. This is that line, the line BC, which gives us 78 and gave us this angle here of 78.69. Always draw it separate, guys. It will make life very easy for yourself. This is that line going up there to A. This is going to point A, this is going to point B. So now we have got this one here, which gives us 123.69. Can you see, guys? So therefore you've got these two angles, but however, this is R, né? Okay, however, guys, this thing that you see here is a triangle. Let me just get a different color so that you guys are able to understand what I'm talking about here. I think a blue color will do. This one here and this is a triangle, this one, as you guys can see. And then we are looking for this angle. This one here forms an exterior angle of a triangle. Therefore you would remember from Euclidean geometry, what do we say? Exterior angle of triangle is equals to, in sum, is equal to what? Sum of internal opposite angles. Okay, so now it means now R, which is that angle there, should be equal to this angle that we are talking about of 78.69 sum of, yes, all right. So then plus C, and remember C is equals to that angle there, theta. Okay, remember, guys, from there, this angle here, they're equal because what? They've got equal opposite side. We did state it here, so therefore we can substitute this as being theta. So therefore let's come here, 1 2 3. We're just substituting R 0.9 is equals to 78.69 plus C. Okay, I'm just gonna put theta here, guys, because now we already know that angle C is equals to A because of this reason here that I've already put it here, guys. Please don't forget. So therefore we're gonna come here and say, okay, 123.69 negative 78.69 as well. Let's do it together, guys, on our calculators and see what we're gonna get. 123 minus 0.69 minus 78, which gives us 45 on the dot. Makes sense. Very good question, interesting question, guys. Like I promised you that the last question is one of the questions that you would really like to see. So I am Gaston Mapala. Let me see you on the next one. Let me know what you think about the last question, which is question number 4. It was worth 6 marks. You don't want to mix these 6 marks because this could be the 6 marks that is taking you from level 5 to level 6, guys. I mean, really, just watch this channel, like the video, share it with your friends, your classmates, to make sure that they also learn as well. I am Gaston Mapala. Let me see you on the next video.